Hello guys, welcome back to my channel. In this video we will be discussing about data preparation. For data preparation, we need to first collect the data. We need to collect the data that is relevant and help us to solve our problem. Depending on the problem we are trying to solve, we will be collecting new data, or otherwise we will be using the data that is available open source. We can have unique problem and that no related searches are done upon it. We will have to be collect new data on that subject. For example, if we want the information on the average time that employees spend in the cafeteria across company, there is no public data available on this, but we can collect the data from various methods such as surveys, interviews of employees, and by monitoring the time spent by employees in the cafeteria. This method is time consuming. The other method is to use the data which is readily available or collected by someone else. These data can be found on internet, in news articles, government census, magazines, and so on. This method is less time consuming. One of the famous places to collect data on the internet is kaggle.com, where you can find thousands of data sets. So after we got the data, before we start to analyze data, the next step is to clean the data. Here we will be doing various operations on data, like eliminating the missing values from the data sets. We have to so that we can perform the better statistical analysis. Data preparation includes the following tasks: adding an index value, changing misleading field values, re-expressing data as numeric data, standardized numeric data, identifying the outliers. Now, adding an index field. For example, not all datasets come equipped with an ID field. Thus, we can add an index field to the data, which will serve two purposes. It acts as an ID field for the datasets without such a field, and it tracks the sort of order for the records in the database. Here a simple example is given in which we have created a data frame which has two columns, name and age. So if you display the data frame, the default index is already present in it. Now changing the misleading field values. Misleading values in a data set are those that misrepresents the actual data. They may not accurately reflect the reality. For example, default values like 999 used to represent missing data lead to incorrect analysis. If not corrected or handled properly, they can skew the results. Common examples are placeholder values like 999, -1, etc. used instead of NaN, missing data. Logical errors such as negative ages or unrealistic values like age in -1 values like and height of 2000 centimeters. Typos such as male written as MAEL, which is an incorrect spelling. The process involves identifying and replacing these values with something meaningful such as NaN, NaN for missing values, corrected values if there is a valid replacement, default or calculated values. For numerical values, we can replace them by mean or mode. That is more feasible. Import Here a small example is given in which we are trying to replace 999 with NaN in the age column, and we are replacing -1 with NaN in the salary column. Here we are using dot replace function to replace the 999 value, and in the salary also we are using this function. The next one is re-expressing data as numeric data. Re-expressing data as numeric data involves converting non-numeric categorical or textual data into numeric formats so it can be used effectively in mathematical operations, statistical analysis, and machine learning models. Here we map the rating to custom numeric values. Here rating underscore mapping is excellent. We have mapped this rating excellent, good and fair to 3, 2 and 1 value. We have encoded these ratings. As you can see in this output, city encoded, it comes to be 2101, which is 2 stands for good and 1 for fair. and 2 for good. Also, rating encoded is also seen here. The next is standardized numeric values. Certain algorithms perform better when the numeric fields are standardized, so that field mean equals 0 and the field standard deviation equals 1 as follows. The formula for standardization is standardized value is equal to x minus mu upon standard deviation. Here x is the observation, mu is the mean, and this is the standard deviation in the question. Importing necessary libraries. We have to import pandas library, numpy libraries, and from sklearn.preprocessing we have to import standard scalar. Now step 2 will be create a data set. Step 3 will be standardize the data. Identifying the outliers. So what are the outliers? Outliers are the data points that significantly differ from the majority of the data. They occur due to errors, variability in the data, or rare events. In this example, as you can see in the age, you can see 1000 is an outlier because 1000 can never be an age of a human. Salary, in salary minus 3 lakhs is an outlier because salary can never be in minus. So we create this data in a data frame. Convert this data into a data frame. Now we can identify the outliers using z-score. Z-score method flags data point far from the mean. The formula of z-score is z is equal to x minus mu upon standard deviation, where x is data point, mu is the mean of the data, and in upon there is a standard deviation. From here we have import the z-score and calculated the z-score. Outliers is equal to df z-score less than 3 dot any axis is equal to 3 print outliers. Here we can see the output as age 100 is the outlier and salary minus 3 lakhs is an outlier. Now we move to the Google Colab for demonstrating this data preparation. First, we are adding an index field, import pandas as PD, and we are loading the data set of an ID's power. So let's run this command, and we have added the index field here. And from the data.head command, we are displaying the first few rows of the data set. So here you can see this field values are changed to 0, 1, 2, 3 and 4. Replacing the misleading field values. In this data species is equal to data species, we have replaced the species name. Here as you can see in the output. The next is convert categorical field to numeric. In this we have converted the categorical field values to numeric values, and we have encoded this to numeric values. As we run this command, we see that here the encoded values are 0, 0, and you can see this in this output. Now the fourth one is standardized numeric field only. In this we have explicitly select the numeric columns for scaling. We have used the standard scalar which we have imported from this sklearn.preprocessing library. Here you can see we have standardized the numeric values in the species encoded column. And the last one is identifying the outliers using IQR. IQR means interquartile range. As we run this command, we can see that we have identified the outliers, and here the index with 0, empty data frame. We have no outliers here. Thank you, and like to this video and subscribe to my channel.